Hi guys, welcome to Science in 5. Salt hydrolysis and pH. When a salt undergoes hydrolysis, it splits into its composite ions, cations and anions, or the positive ions and the negative ions. At the same time, there are ions that are formed by water from its auto-ionization, and these ions mix up and determine the pH of the solution. So the first example, I've got hypothetical salt solution Ma. M represents the positive part, cation. A represents the acid radical. So Ma ends up being split into M plus and A minus. Both of these are aqueous in solution. At the same time, we have H2O undergoing auto-ionization to form H plus and OH minus. What then happens is the ions that are formed somehow exchange. So we end up with MOH aqueous and HA aqueous. And the base and the acid now determine whether the solution becomes acidic or basic. Base is strong, acid weak, basic solution. Acid strong, base weak, acidic solution. Equal strength, neutral solution. Okay, now this reaction can be actually summarized. We don't have to write all these reactions, so we can write a short version of this reaction. What is the short version we're going to write? Well, since we know that Ma is going to react with water and it's going to form, there's going to be an exchange of ions. We're going to end up with MOH aqueous, and the H from the water goes to form an acid HA. That's the basis of the argument that we're going to be using in this video to explain how a salt can influence the pH. So NaCl aqueous, we react that with water. We're going to end up with NaOH plus HCl. Okay, if you can actually write those two long equations to prove that we got this right. Now here we can easily see that the base is strong, the acid is strong, so this solution is neutral. So this salt is classified as a neutral salt. Okay, jumping on to the number 3, potassium ethanoate. Right, potassium ethanoate, that's the correct formula. We're going to react it with water again. Remember, the water splits into H plus and OH. The OH goes to the metal. We end up with KOH. The H from there goes to the acid radical. We end up with CH3COOH aqueous and aqueous. Here we can clearly see that KOH is a strong base, ethanoic acid is a weak acid. So this is a basic salt because the pH of the solution is going to increase because of the KOH. Go on to NH4. NH4 solid, we're going to react it with water again. There's going to be an exchange of ions. The OH goes to the positive part. You end up with NH4OH plus. The H goes to HCl. These are all aqueous ions. You can see that there's a strong acid and a weak base. This is going to be an acidic salt. In the case of ammonium ethanoate, here you can easily see that we're going to form a weak base, NH4OH, and a weak acid. Both of them are aqueous. So because they're weak, so this is going to be again neutral salt. So that is how you can prove that a salt can change the pH when it undergoes hydrolysis by writing these equations. Thanks for watching.